was the ice sheet that was not very much affected by climate change. But today, that has changed completely. Today we're seeing accelerated loss of mass and loss of ice into the ocean in Antarctica.
West Antarctica would lead to sea level rise of more than 5 meters if it were to melt down completely. And then East Antarctica actually holds the tenfold of that, so more than 50 meters worth of sea level potential.
Ricarda is one of Johan's colleagues, and she studies how tipping points can interact.
The important point to make here is that everything in the Earth system is connected. If one part of the climate system crosses its tipping point, then that might make it more likely for other parts of the system to also cross their critical threshold. So you can think of this in terms of dominoes. If you tip one of them over, then this might lead to a cascading effect. What is clear is that with ongoing global warming, we're increasing the risk of crossing tipping points in the Earth system.
When we cross tipping points, we unleash irreversible changes. That would mean that the planet will go from our best friends to a position where it dampens and reduces the stress, sucking up carbon dioxide, taking up heat, absorbing impacts, and tipping over to a point where it could self-reinforce warming and become a foe.
The climate is, of course, being warmed by greenhouse gases. So it's in our emissions of these gases that we find a global tipping point. Since long before human beings appeared, the Earth's average temperature was closely tracking the concentration of carbon dioxide in the atmosphere.